Hello everyone, welcome to this session. In this session, we'll go through RMG website and show you some of the features available there. So on the right, you can tell it is the agenda for today's tutorial. Please feel free to open a web browser on your local machine and follow the instruction here while you are watching this video. So let's begin. So RMG website is hosted at rmg.mit.edu. So you can visit this by entering this address into your web browser. And I guess many people will ask, since I already installed RMG and RMG database in your local machine, why do you still want to use RMG website? This is a good question. So, RMG database is written in Python as well. So it's more generally like text. And, finding things in a huge list of text is very difficult. And here, RMG website provides you a very convenient GUI, to query, say, some species you really care about or some reactions you want to know. And many people find it very useful, and this is generally the reason why we want to introduce this tool. Okay, so you can tell on the left, we already opened a page of RMG website, and this is the home page. So I guess for each page of RMG website, it's about the same. So so on the header, there's usually a change theme button and something about your user account. We highly recommend you to register as a RMG website user so that there are some advanced features that are only open to a website registered user. So in login, there's a create one now, so you can create an account in this page, and probably when there's another training or some important news, we can send it to you. And let's go back to the main page. Okay, on the left bar, you can tell there are the most commonly used features of RMG, and today we'll go one by one to introduce each of them. And the main body of the page will be the content of each feature. So this is the home page or the index page of RMG website, where we listed some introduction of RMG, where to find the package and source code, and some of the contact information. On the bottom, there is also another thing called RMG users mailing list, which is a kind of more broader idea, slightly different from RMG website users. So please also remember to register this mailing list so that you can receive the latest news from us, including say the some of the big releases or RMG workshop tutorial informations. Okay, so let's begin with the documentation for today's introduction. So in the documentation page, you can tell this is the RMG documentation. Actually, there is a local version that already installed in your RMG Pi directory, but I find people find this online web page more useful because it is more straightforward and more interactive. So it lists the RMG user guide, which you can tell how to install RMG, how to create input file, how to run jobs, and some of the advanced features are introduced as well. So people put a lot of effort to write each content, and they are really comprehensive. Please feel free to check it out when you have problem running RMG or you want to learn more about RMG features. And there's the Arcane. Arcane user guide is almost the same about RMG. For those you who don't know Arcane, Arcane is a submodule of RMG which can, calculate thermal properties or transition state theory rates. And there are also theory guides. So in the theory guide, we include some of the basic theory that included in RMG. For example, how RMG expand its reaction networks. So if you are interested in the theory, also feel free to check it out. And it also contains API reference. So in the API reference, when you try to develop RMG, or if you want to integrate RMG in your package, you can look at its API, and it will tell how to import the package from which module, and what are the arguments used for each functions or class. Right. This is all about the documentation part. Let's go back to the RMG website. So the next bullet point is the resources. So in the resources page, we list some of the useful information here. Say, for example, the publications. If you use RMG in your research work, please cite us according to this publication list. And the second bullet point is RMG workshop recordings. So far there is one set of recordings available. So if you click this link, it will direct you to a YouTube list where you can find a bunch of videos, just as what you are looking now. And after we making this set of sessions, we will also upload it here. So if you want to, review some of the content, you can definitely go to the RMG website and find it here. There are also some things that people use for, actually we use internally for our study group. So it includes some of the software basics, some of the kind of the interesting knowledge, or some of the advanced features are included in RMG. If you are interested in some of them, feel free to check it out. And this is the resources page. Then let's go to the database. Database is kind of the most important part on RMG website. As I mentioned, the local RMG database is just a plain text, and on the RMG website we provide plenty of uh, tools to help you understand the database we have. So here we list all the database we included. For each database, we have a search function, and inspection function. So for search functions, we'll introduce them later in these sections. And for now, we'll just look at some of the inspection functions. For example, let's go to the thermodynamic libraries. So here is one page of thermodynamic libraries. So people generally so in this sort of libraries, it usually stores some of the high quality data that are already available from either publications or calculations within our group. So say one of the libraries that almost all RMG model use is the primary thermal library. So let's click it in. So you can tell what species are already included in this library. And if you further click one of the item, you can check out what are the thermal data for them. And if you are trying to, compose a Chemkin model file by yourself, you can also copy paste this section into your model file, which is really convenient. So this is for thermal libraries, but generally it's all about the same for kinetic libraries, transport libraries. They have almost the same framework, and you can check whatever you want by going through this list. And another thing people find it really useful is the kinetic families. So in the kinetic family page, let me go into this. So in the kinetic family page, it listed all the reaction families defined in the RMG. So RMG use defined families to generate new reactions. So it is very important to know what are they, and how to, and what's the quality of them, or how rate estimations are made. So on the left, we listed all the names for our families, and let me on the right, we list all the graphic templates of each family, so you can tell what reactions maybe belong to one family. And on the middle, you can check out, say, if the estimation is made by group additivity, what are the groups being used? If the rate is being is rate estimation is made by rate roles, what are the roles we included? And what are the training reactions we included to train our rate rules? So yeah, I think a lot of other repositories, say for example AutoTST or Kimbot, also refers to this family list uh, to generate reactions. Okay, so generally it is about this. This is all about the database page. So in the database page, we tell you how to inspect the kind of the list of what are the atoms available in our database. And let's go to the molecule search or kinetic search or observation search part to check if, say, for example, if you want to query just one reaction, you don't really have to go through the list. You can just type in the information of the molecule or the reactions you care about, and RMG website will just give back what you are interested in. So this is the molecule search. Actually, it is the most popular page we find in the whole RMG website. So for the molecule search, it allows several kind of inputs. Say, for example, you can input a structure by just drawing the structure, right? It will provide you the adjacency list of ethylene, and when you click any of these buttons, it will provide you the information of ethylene. Or you can simply type in the name of the species, say the same. So if you just type the name of ethylene, it will bring back you the same thing. And yeah, when you click the button, it will give you the result. Or you can type in the smiles. The smile strings will provide you the same thing. Let's change another example. Say for example, methane is just C, so type in C, it will bring back this information to you, and you can now click any of the button. So after I introduce how to input the molecule information, let's look at how each button works. So in the draw molecule button, you will simply draw a molecule and provide you all about the basic information for this molecule. So including molecule weights, some of the identifiers and its name. And this is quite basic. And if you want to learn the thermochemistry of the molecule, you can go into the search thermochemistry button, and you will pump out all the available data in RMG database that are related to this structure. So for example, as mentioned, the primary thermal library is one of the libraries that contains very accurate thermal. So you can tell what library, so from this list, you can tell what libraries are available, includes this methane properties. There are really bunch of them. And in the bottom, you can probably also always find a entry called group additivity, which is the thermodynamic estimation made by RMG using group additivity method. So from this, you can, so yeah, and for each block, there's also contains a Chemkin block, which, when building Chemkin files, you can just copy paste this block as well. And this is a thermal library search result. Let's go back to this page. So if we click the search transport property, we'll bring back all the transport data that are available in RMG, which is kind of quite similar to what we have for the thermal. And there's also a thing called generate resonance structures. If there is conjugated double bonds, um, or for some, third row or fourth row elements, if they are available, it may have some resonance structures. But for example, for methane, it's simple and there's no double bond. If you simply click this, there's just one geometry. However, if we try to find something more complicated, say sulfuric acid, then this page will bring back all the important, all the resonance structures for these molecules, and it is really useful when you're trying to study some of the conjugated species. Their species have conjugated bonds, and this is about molecule search. Let's go to the kinetic search. You can tell for now we only support at most two reactant or two products on each side. So in this page, it has the same kind of system to search molecules. So you can again here you can type in the name of the species or miles or inches, generally the string structure. You can also type in the adjacency list. However, adjacency list is usually complicated, so people don't usually try to type it, but maybe copy paste from the species dictionary that generated from RMG models. So you can either just type in the reactant information so that this page will bring back you the all the matched reactions that have the reactants you input, or you can type in both reactants and product information, which RMG will try to find the reaction that match your query. Okay, let me do a demo. So for example, for example for methane and oxygen. So this example will bring back you only one reaction since there's only one possibility that oxygen will abstract H atom from methane. So from this page, you can tell RMG find 29 matches in the database, and if you go into this page, it will list all the matches, all the matched library, and the kinetic formula for the entry is matched, right? And at the bottom, there will be a figure that illustrates the difference of each entry. This is an interactive feature. You can get the value or zoom in to look at the details or click the ligand to exclude some of the entries that you don't want to include it. Right, and at the very bottom, you can also make estimations. Say, if I want to know the rate at 1000K, 1 bar, it will bring back the results at the very bottom. Right, and I showed an example of just input the retin information and product, simply the retin information. Now let's do something different. Say, if I want to know an intramolecular H migration reaction, um, so for example, for this, if I simply input the retin information, it will bring me back a list where I have to find the exact match for the H migration reaction I want to learn. However, I can also input the reactant information, extra carbon there. So in this time, it'll bring me back the only reaction that I care about. And this is about the kinetic search. If RMG doesn't find any reactions that matched, it will simply return nothing, as what I have just now. Right, no results found. And this is about kinetic search. Next part is about solution search. So solution search is mainly is kind of an implementation on a GUI implementation for this paper, please feel free to check this paper written by our group members. So, to find in the solution search, I guess all the people want to know is about the solution energy or some of the important parameters for solution models. So, say for example, I want to learn something about methane, um, you know, dissolve in the water. So I can simply type in the methane as a solid and the water as solvent. And by click this search solution, I can get all the important parameters for the solution model or the important thermodynamics properties I care about for right. So this is the 2000 to 98K predictions. You can also check out the temperature dependent predictions when you do something like this. Yeah. Okay, this is about the solution search. And next, we'll look into the pressure dependent networks. So pressure dependent networks is kind of a GUI implementation for arcane PDAP network generation. You can do it locally by your local RMG Pi. But if you are not comfortable with running command lines or dealing with terminals, feel free to check these tools. However, to run these tools, you have to have a registered account. So let me first input my information there. Okay, so you can tell now I have the information. Right, so you can either create a new pressure dependent network or you can check out the pressure dependent network you run previously. To create one, it's pretty simple. You can use the editor here or provide the input file here. So for simplicity, I will just use an example provided by RMG. So, uh, so there's a folder in the local RMG directory called examples, and in the examples you can find scripts, then sorry, arcane, and networks. We'll do these examples, and we can simply provide the input file. To learn how to write the input file, you can go back to the documentation part and check it out. By simply click the submit, will prompt you with the basic information you included in the input file. Say, for example, which species are included in the input file and what are the reactions included. To generate the network and get the kind of a PDAP kinetics, you can simply click the Run Pressure Dependent Networks uh, or the Click Here button. Right, so it will usually take some time. So to save time, I will just show you an example I ran earlier. All right, yeah. So in this result page, you can tell there's a PDAP network that's drawn by RMG. From this figure, you can tell what are the starting reactants and the exiting channels, and what are the intermediate isomers. Uh, right. And you can also look at the output, download the output file, which includes all the kinetics or the rates for each channels. Right. This is all about the pressure dependent networks part. Um, RMG so let's go to the last part, the other RMG tools. So RMG provides a lot of useful scripts, which we will more detailedly introduce in other sessions. And there is also like counterparts in your local RMG directory. However, if again the same, if you are not comfortable to run those scripts in the terminal and command line, you can check the possibility here. So we provide some of the most commonly used tools, say the visualize chemical file, model comparison, etc. here. So for this part, I will just show a quick example of model comparison. So if you click into the model comparison, it will inform you how to some of the basic information about this tool and some of the information you need to provide for this tool. So for example, for model comparison, you need to provide the CAMQ model for each model. And if it is a RMG generated one, you can provide the RMG species dictionary so that it will infer the molecule structure from this dictionary. Or if it's outsourced CAMQ files, you just simply click here to let it know it's not a RMG generated model. So again, we'll use the examples already provided by RMG. So if you go to the examples RMG scripts and diff models, there are two models called DFT cam and the primary cam models. So we can make the input here by providing the necessary information. All right, by simply click the submit, it will run the script. And yeah, so if you click to look at the results, it will prompt you with the results showing all the analysis, trying to figure out what are the differences between the model, if there is any different thermal or identical thermal, etc. We'll look into this page in the later session, but for here, I will just let you know there are some possibilities to run those scripts by RMG website. Yeah, I guess this is all about RMG website tutorial. Please feel free to check the website and please let us know that if you have any suggestions or you find any bugs or problems in the RMG website. You can either email us at rmgdev@mit.edu or raise an issue on our GitHub page. Also, some of the functions that are provided by RMG requires on-demand calculation. This sort of calculation usually take time. And due to our limited resources, please be patient while RMG website is doing this sort of calculation. So please don't overclick because some of the over submission will, occupy all the computation source and make RMG website crash. Right. Thank you for your attention.